Welcome class, this is Mr. D teaching you stoichiometry and mole conversions. Remember, when we do stoichiometry or molar heat, we need a balanced chemical equation. This means when we go mole to mole or mole to kilojoule, we need an equation. So step one, balance that equation. Then look at the problem. Start with whatever the problem tells you. In this case, A starts with 7,110 kilojoules. You immediately want to times line and bring kilojoules to the bottom. The only place we have kilojoules is in the equation. You can see we have got kilojoules right over there, and so that is what we are going to use, the 3,120 kilojoules. Since we grabbed one number from the equation, we must grab the other. In this case, we want to go kilojoules to moles, moles of O2 to be particular. So we are going to need our moles of O2 from the problem. That would be 7 moles of O2 over my 3,120 kilojoules. I punched this into my calculator, putting what was on the top as a multiplication. On the bottom will be division. In this case, 7,110 times 7 divided by 3,120. We could have done it the other way, divided then multiplied, doesn't matter. Either way, we're going to get 15.95 moles of O2. For my next one, I am starting with 9.2 times 10 to the 24th molecules of CO2. We're still going to times line, and we're going to bring molecules of CO2 down. And in this case, we are going to change it to moles. Since we're going to need to go to heat, we want to change it to moles. We cannot go molecules to heat directly. We have to go molecules to mole, then mole to heat. Molecules to mole is the second conversion we went over. 1 mole is equal to 6.02 times 10 to the 23rd molecules. Now, since this is math under a line, we need parentheses around our 6.02 times 10 to the 23rd. Whenever we have math under a line, we will need parentheses. We are not done because we want to go from moles to kilojoules like we did in the last problem. And in the last problem, it'll be 3,120 kilojoules, but our CO2 moles are just 4, as you can see over here in the problem. In this case, I'm going to punch in my number. Make sure you use your caret if you are trying to do an exponent or whatever your calculator needs. So 9.2 times 10 caret 24 divided by parentheses 6.02 times 10 caret 23 end parenthesis times 3120 divide 4 equals. And I'm going to get a big number here, but that's okay. I just want to sit there and make sure I write it down properly. 1192.0.2. Now, the next one is a 6.5, but that's just going to become 7 with our rounding for ChemCom. In chemistry, we would use sig digs, sig figs, but that's a different topic. Chemistry will have a different video. Remember to box your answers when you're done to make your teachers' lives easier. For our next one, we're going to start with 22.5 grams of ethane, which is C2H6, times line. Immediately bring grams of ethane straight down. Now, a lot of people want to go gram to gram, but that does not happen. There's no such thing. We need to go gram to mole, which would be our first one that we went over. 1 mole is 30 grams in this case, because 2 C's is 24, 6 H's is 6. Add them together, you get 30. Now that I'm in mole, I'm going to go from mole of C2H6 to what I want, moles of H2O. there are 2 moles of C2H6 to 6 moles of H2O. Again, I get this from the equation. I've got my 2 and my 6, both from the equation. Now, continuing on, I don't want moles, I want grams. So I'm going to bring my moles of H2O down, change it to grams of H2O. This is the first conversion we did, but we're going to do it again. This time it's 16 to 1, and that is because water is 2 and 16. Add those together, you get 18. All right, and then in that case, we do the math. We do our 22.5 divided by 30 times 6 divided by 2 times 18, and you should get 40.5 grams of H2O. Put a box around it to signify that it is done. Moving on to our last question. We start with 6.7 grams of CO2 times line, grams of CO2 down. Now we can go directly from grams of CO2 to molecules of CO2 using our transitive property, meaning that our 6.02 times 10 to the 23rd molecules, which is a mole, is also equal to the molar mass in grams, again, equal to a mole. So together, we can just put them into one problem and then solve and make our lives simpler and easier. This did not use the equation at all, as this is just a mole conversion, not stoichiometry, not molar heat, just a mole. 9.17 times 10 to the 22nd molecules of CO2. Put a box around it to make our teacher happy. Last but not least, is this endothermic or exothermic? It is exothermic, and the reason for that is because heat is after the arrow. Heat is after the arrow. So it is exothermic. So there you go. That was a crash course in the mole and in stoichiometry. There are cleaner versions of this on the PowerPoint, which has been shared online through Schoology. If not, take a look, see what it was. Remember, you may watch this video again, and you may pause it, and you may stop it. You may rewatch it if you so wish. Take care, have a good day, and good luck.